Okay, example 7 is pretty much a direct application of what we just learned in the inclusion-exclusion rule. So we're going to be first calculating how many students scored 12 or above on at least one quiz. And in order to do that, I'm going to basically use the formula. In this case, I have three sets. The set of people that scored 12 or higher on quiz 1, I'm calling that set A, then set B, and then set C. Okay. And we have all the numbers for every set individually. We have the numbers of sets A and B and C, B and C together, and finally the people that scored 12 or higher on all the quizzes. Okay, so we're gonna start by calculating the amount that we want. So this is the amount of 12 or higher on any quiz. So the number of people that scored 12 or higher on quiz 1, or 12 or higher on quiz 2, or 12 or higher on quiz 3. That's basically the total of N, A union B union C. This is what we are looking for in this problem. It's going to be the total of A plus the total of B plus the total of C, but obviously we're going to be over counting this way. So now we're going to take away all the possible combinations or permutations or whatever you want to call them of any two sets, A and B, or A and C, or A and B and C, let's say. And then we're gonna re-add the one that we missed or that we took out too many times, A inner B inner C. Okay, so I'm basically just pretty much remembering the formula that's written over here. I'm just kind of remembering it and writing it down on the paper, and just I'm gonna take away all the numbers and plug them into the formula. Okay, doesn't fit in one line, that's why I kind of wrote it like this. So first 15 for A, then 12 for B, then 18 for C. Now we're going to take away the A and B combo. So A and B, that's basically this one, A and B. Okay, so that's this, which is 7. Then we're going to take away A and C, so that's 1 and 3, A and C. And that's going to be 11, minus 11. And then take away the B and C, so that's 2 and 3 groups, B and C. That's a total of 8 students. And then we're gonna re-add the people that scored really high on quiz 1, quiz 2, and quiz 3. And that's gonna be 4 people. Okay, so putting that in the calculator, what do we get? So the total is 23. Okay, so that's how many people scored 12 or above on at least one quiz. Okay, so I reorganized the problem so that you can see what every number corresponds to in terms of the formula. Let me make a little Venn diagram over here and put all this information in a Venn diagram. So in this Venn diagram, the circle in red is going to represent quiz A, or quiz 1, group A. The blue circle is quiz 2, which is group B, and the green circle is going to be group C, or quiz 3. So first of all, I know that there were 4 people that scored 12 or higher on every quiz. So the inner circle, the little triangular looking area, is going to have 4. Okay, so that's shared by all the circles. So that's why there's a 4 right there. Okay, now let's figure out. There were 8 people that scored 12 or more on B and C. Okay, so it's basically the blue and the green circle. And there were 8 in total in that little section. So this whole section contained 8. 4 have already been accounted for, so 4 are going to be left to go inside that second half. Okay, now in the circles 1 and 3, in quiz 1 and 3, there were 11 people. Okay, 1 and 3, that's red and green. There were 11 people in that section, and 4 have already been accounted for, so how many are left? Well, 7 are left. And now finally, between quizzes 1 and 2, there were 7 in total. So that's basically the blue / red, 7 in total, but there's already 4 in that whole space. So how many are left to get to 7? Just 3. So that's how we get to that. Now inside the green circle, there were 18, but I already have 4 and 4 and 7 inside that circle. So to get to 18, I need 3 more. So that's how many are going to be in that section. Now inside the blue circle, there were 12 people, and I already have 11, 4 plus 4 plus 3, so there's only 1 person still missing. And then finally inside the red circle, there were 15 people in total, and right now I have 14 accounted for, so only 1 person is missing. Okay, So if I did the Venn diagram, I can calculate the 23 for you very quickly, very easily, by just adding up all these numbers separately and taking out the differences of the overlaps, and that, that will be a convenient way of doing it. So if you see, add 1 plus 3 plus 1 plus 7 plus 4 plus 4 plus 3, and you'll find out that the number is automatically 23. So that's kind of what we were hoping for. That's what we got from our calculation. Now, if you added the original numbers, 15 plus 12 plus 18, you would not get that same amount. You would get a totally different amount because some of the circles were overlapping. As a matter of fact, all the circles were overlapping. So that's the reason why we cannot use the addition rule. We have to use the inclusion-exclusion rule for this problem, okay? All right, let's look at part 2, which says how many scored 12 or above on quizzes 1 and 2, but not on 3. So they scored, remember the quiz 1 was the red circle, that's the quiz 1, the quiz 2 was the blue circle, and quiz 3 was the green circle. So we want the people who are in 1 and 2, but not in 3. So we want them to be basically right inside that little triangle, okay? That's how many people scored 12 or above on quizzes 1 and 2, but not on the third quiz, okay? So why am I not calculating this guy and this guy on the sides? Well, the one that we have right there is a person that scored 12 or higher on quiz 1, but not on quiz 2, so he doesn't count. Same thing with the one on this side. What about the 7 and the 4? Why am I not counting those? Well, again, the 7 is a person that scored 12 or higher on quiz 1 and quiz 3, and we don't want that. We want the quiz 1 and 2, but not 3. So the total that we're looking for is 3 people. So the number of people is 3.